final thing I want to discuss for today's lecture is a little bit more information about streams and also some guidance on how you can test functions that work with streams. So basically a stream is going to be an abstraction over either input or output. If we're working with input, then the stream might be called the source for our data. And if we're writing output to a stream, then we'd be writing that output to a sink. Source and sink are opposites in this context. Streams in C++ are generally going to support input and output based on characters, so sequences of letters and numbers and symbols. We've already been using them in our code in a variety of contexts, so cout, cin, file input output streams, and so on. Many of the streams in C++ actually belong to some common hierarchies. So it turns out that things like, for example, cout and of streams are both different kinds of O streams. And if you've actually seen like a function that performs output, like maybe some of the functions on the project, you'll notice that the parameter type for those functions is an O stream reference. And what that means is essentially it's a flexible parameter that could take in either cout or an output file stream, depending on how you want to use the function, because both of those different things would conform to the same O stream interface. Same kind of thing goes for input streams. We have iStream, which exists on top of things like cin or an input file stream, etc. And then at the end of today's lecture, we'll be looking at two more different kinds of streams, which are string streams, that basically allow us to like send output into a string or read output from a string rather than from something like a file. So we'll look at those in more detail in just a moment. First, I want to cover a little bit more about the insertion and extraction operators, which are our input and output operators. So first, this one, the insertion operator, is called the insertion operator because you're like putting data into a stream when you're doing output, and then that data like flows onto the terminal. When you use this operator, the behavior that you're going to get is actually going to be specific depending on the type of value that you're inserting into the stream. So let's say you send it a character. Well, that's just going to put a single character into the stream, nothing super exciting. But if you send it a string object, then it's going to take all the characters that exist in the string and send them out into the stream to be printed out of the terminal. If you give it a double, it's going to format the double in some floating point notation with a decimal point and a certain number of, like a certain amount of precision. So how many decimal places do you want to see? And finally, we have this special behavior we've seen for C-style strings, where if we send a character pointer to cout using the insertion or the output operator, then the compiler essentially assumes that it's pointing to a C string, and it'll run through memory printing out characters until the null character is reached. On the other hand, if we're doing input, we've got the extraction operator, so called because we are extracting data out of a stream. So if we're using like cin and we use this operator, we're pulling data out of cin. And again, the behavior that we get is going to be specific depending on the type of object that we're extracting into. So for several different examples, if we're reading like say characters, we only get one single character from the stream, but if we're reading into a string variable, then it's going to read in a whole word at once up to the next piece of white space. Or if we're reading in numbers like integers or doubles, then the input operator is going to attempt to interpret the character data that we get from the stream as if it were a number. So instead of reading in for an int like, the character's 437, it would read in the integer value 437 for us. And finally, just a little bit more information about how these operators work in terms of the language itself. Both of these operators are binary operators, just like plus, for example. They take two operators, or two operands, a left-hand side and a right-hand side object. The left-hand side is always going to be the stream that we're working with, like cin or cout always comes on the left of one of these operations. For the output operation, the right-hand side is going to be the value you want to insert into the stream. For the input operation, the right-hand side has to specifically be an object, not just a value, because we need an object that is like some chunk of memory where we're going to actually store the value that we get out of the stream. And these operators have two parts to them. And the second part is probably the most significant one. But first, the first part, the one we're familiar with, we're reading and writing into or out of the stream. That's familiar already. But the evaluation of these operators is actually kind of peculiar. When we evaluate something like, x plus y, then we get their addition, right? So maybe those two things add together to give you the number 7. But when we evaluate something like cout of like some value, then that whole thing is going to evaluate back into cout. And the reason it does that is to allow the chaining of several different operators together. So take a look at this line. If we're looking at this binary operator here, it's got a left-hand side, which is cout, right-hand side with it, which is this string, then that whole piece is going to evaluate back into cout, which means then that cout gets paired up with this next piece of output, and that thing evaluates into cout, and then that cout gets paired up with the next output, and so on, which allows us to do multiple different cout operations on the same line. All right, I know this is a long segment. There's one more piece of miscellaneous information for you, which will actually turn out to be helpful on project 2. And this is how to use string streams to help test functions that normally do input and output to other different kinds of streams. So let's start with iStringstream, which is going to be a string stream intended for input. It's an input stream that instead of reading from like a file or from the terminal, uses a string as its source. So let me make that a little bit more explicit. If we've got fin, then we might read some data from fin that is ultimately coming to us from a file that's got some information. If we've got a string stream, so iStringstream in our code, we're going to be reading some data from that is ultimately just coming from some string variable in our code. And I've said that this is helpful for testing. The reason why it's helpful for testing is if we've got a function like, say, the function that is intended to read an image from a file stream. Well, if we were trying to read an image from a file stream, then our tests would actually need to keep track of a separate file. And that's no good because we want the tests to be pretty well self-contained. Instead, if we used a string stream to read into that image, then all we need is inside of our test code to have a string variable that stores the input we would want to test with. And that's what we're doing here in this example. So let's take a look at this one in particular. What we want to do is ultimately test this image init function to see if it creates an image that is correct based on some input we get. Now, normally that input could come from a file, but that's inconvenient for our tests. So instead, we're going to take that input and literally hard code it into a string in our test function. And you'll also notice that in this string, I've got things like new line characters in places where I expect there would be a new line in my file input. And so what I'm doing is with a string literal or a set of string literals, I'm simulating the input we would get from a file. Then I take that input, use it to construct a string stream, which I'm calling SS input here. It's specifically an iStringstream because we're intending to use it for input. And then I pass in that iStringstream SS input into my image init function in the place where I would have normally gotten some other stream. Once I've done that, image init is going to read from that iStringstream just the same way it would have read from a file stream, and I can go ahead and write in some assertions to check things that should be true about that image. Going the other direction, if I wanted to test a function that was normally supposed to produce some output, I can do something pretty similar. So here I'm going to set up a matrix with some data in it, fill it with zeros, put ones around the border. Then I'm going to go ahead and hard code a string literal that has whatever is my expected output, what I expect to get if I say were to print this matrix using the matrix print function, which is like on the first line a bunch of ones, second line has a 0 in the middle, third line is the bottom has some ones. Then I'm going to create an O string stream the O here because I'm going to use it for capturing some output. Then I'm going to call matrix print, and instead of telling it to print to a file, I'm going to tell it to print to that ostring stream. And then finally, I'll access the data within the ostring stream using the .stir function, and I can take that output that was captured by the ostring stream and then compare it against my expected correct output that I had hard-coded into the test from earlier. So again, the idea is to write some tests that are self-contained with the input here that then gets put into a string stream, and then that string stream is used in place of what might normally be like a file stream in our tests.